All right, here's the steps for hypothesis testing using the traditional method. Step number 1, you state the hypothesis, identify the claim. Step 2, you find the critical values. Those are going to be either z-values, t-values, or chi-squared values. For lesson 8.3, we'll be using z-scores. Step number 3, compute the test value. The test value, again, is going to be either a z-score, a t-score, or a chi-squared score. For lesson 8.3, it's going to be a z-score. Step number 4, make the decision to reject or not reject the null. And step number 5, summarize the results. Okay, this is number 6 on page 415. It says the average production of peanuts in the state of Virginia is 3,000 pounds per acre. A new plant food has been developed and is tested on 60 individual plots of land. The mean yield of the new plant food is 3,120 pounds. So does that sound like the yield went up or not? It went from 3,000 to 3,120? Yeah, but is that enough to be statistically significant? Or is it just sampling error that just happened to go up by chance? That's what we're trying to determine. The mean yield with the new plant food is 3,120 pounds of peanuts per acre with a standard deviation of 578 pounds. At alpha equal 0.05, can one conclude that the average production has increased? So we're trying to determine, we know the average was 3,000 pounds per acre. What we're trying to determine is, has the average gone up? So we're going to start, step number 1. We're going to write out our null hypothesis and our alternative hypothesis. The question is, has the average amount per acre gone up? Has it gone above 3,000 pounds? Yep, 3,000 pounds per acre. And that's what they're asking about. We're going to call that the claim. Whatever they're asking, that's the claim. They're claiming that it's gone up. They're claiming this new plant food that's been put on the... I mean, no farmer is going to want to use it if it's not increasing their yield, right? Why spend the money on it? Okay? I put that in the bottom because there's no equal bar. It said increased. It didn't say stay the same or it increased. So our null is going to be that the production of pounds per acre is either stayed the same or gone down. Again, that's in pounds per acre. Step number 2, find the critical values. What did it say alpha was? 0.05. Looking at this sign in the alternative hypothesis, you should know this is a right or left tail. Which one is it? Right tailed. If the bottom symbol points to the right, it's right tail. This is a right tail test. Alpha is 0.05, so this area right here called the critical region or the rejection region is 0.05. Let's find this critical value. If that's 0.05, we take 0.5 minus 0.05, this area would be 0.45. We go to our z-chart, look up 0.4500, and that'll give us our critical value. Anyone tell me what it is? 1.65, thank you. So our critical value is 1.65. Our mean in the middle here is 0. So this is what's going to happen. Now we're going to take our sample average and our standard deviation. We're going to calculate a z-score. It's called a test value. If that test value falls in the critical region, then we're going to reject the null, which means our evidence would support the claim down here. If our z-score falls in the white region here, that's not the non-critical region, then we're going to not reject the null. Then we're going to say, oh, the results of the test were close enough to 3,000 that we're going to say that the increase in production of peanuts isn't really statistically significant. It was just due to chance. Okay? So our next step is to find a test value. Step number 3, we're going to do our test value, which in this problem is a z-score. Notice we have a sample size greater than 30, so we're going to be using z-scores. So z equals x bar. X bar would be the sample average. What was the sample average of pounds of peanuts per acre? What did it say in the problem? What says? Yep, a new plant food has been developed and is tested on 60 individual plots of land. So n is 60. the mean yield with the new plant food is 3,120. So X bar is your sample average. 3,120 is the average of the sample. Subtract off your hypothesized average, which is 3,000, divided by the standard deviation, which in the problem said was 578 pounds, divided by the square root of 60, because they had 60 plots of land in their sample. Make sure you put parentheses if you're going to try to type it in all at once. Anyone tell me what that comes out to? It should come out to a positive number, because I'm taking a larger number minus a smaller number, so I get a positive, and the denominator will always be positive. Anyone tell me what that is?
1.608.
Okay. So what that's telling me is this 3,120 pounds of peanuts per acre that came about in the sample is about 1.6 standard deviations above the mean. So 1.6 would be 08 would be about right there. Our test value falls about 1.608. The magic line here was 1.65. If it would have fallen above the 1.65 line, then we'd say yes, this new plant food definitely, well, I can't say definitely, but we would say that the results were statistically significant. In this case, 1.608 does not fall above 1.65. So it's close enough to 0 that we cannot reject phenol. It's 3,120 was too close to 3,000. It didn't go up enough for us to say, to reject phenol. So step number 4, we're not going to reject phenol. This white area is the non-rejection area. If this purple value would have fallen in the tail here, that would be the rejection region. So step number 4, you're always going to say reject or do not reject phenol. In this case, do not reject phenol. Step number 5, we're going to summarize. When you summarize, you're always going to say something about the claim. And I want you to look in your book. There's a nice little chart that explains this on page 409 in your book. Page 409, at the top, there's a nice chart there. What it says is that basically if the claim is in the null, if the claim is on the top line, you're going to use the word reject. If the claim is in the bottom line, you're going to use the word support. So if the claim's up top, you're either going to reject or not reject the claim in step 5. If the claim's in the bottom line, you're either going to support or not support the claim. So in this case, if we're not rejecting the null, that means we basically are thinking that it's probably true, which means we should reject the second line, we should reject the claim. But we're not going to use the word reject, okay? We're supposed to use the word support. So how can if we are not rejecting the null, we think it's true, that means we cannot support the claim down here, that the production has increased. So this is how we're going to word it. There's not enough evidence to support the claim that the peanut production has increased. Okay, so step 4, you're always going to either reject or not reject the null. Step 5, you're going to talk about the claim. If the claim's in the top line, you're going to reject or not reject the claim. If the claim's in the bottom line, you're either going to say support or not support the claim. Any questions about that? Go ahead and shut that on.